So today we'll be doing activity questions of week 7. Okay, so before we proceed, let's collect some feedback on quiz 1. Okay, so anyone wants to add some feedback on quiz 1? Like how was your experience? How was the paper? Was even see it was the first exam that is proctored in stat 2 also it was online. So yeah, just give your feedback whatever you have. Am I audible? Hello. And I don't know what you. Hello everyone. Good evening. This is Ankur Upadhyay, Statistic Course Instructor. Okay, so today we'll be doing week 7 activity questions. So before we proceed with week 7 activity question, let's quiz 1. So I just wanted to know regarding quiz 1. Uh, okay. Let's start with Bimlesh Dipian. Okay. You can use your mic.
Hi, Dinesh here. Hello.
Uh,
Hi, Ankur Dinesh here. Got
yeah,
all.
yeah. Yeah, this is not audible. Like, can you speak little louder?
Is it audible now? For I don't know whether others can
Yeah,
hear.
yeah, yeah, yeah.
Yeah, I mean, for me, it was stress quite
Yeah,
good,
yeah.
and I could solve all of them correctly.
Okay, okay, okay. That's very good thing. Okay, so any feedback you wanted to add, or it was fine for you?
And
Totally fine.
it was fine for me. Ma- it looked like sometimes it looked like calculation intensive, but it was not like p x z equal to 1. So the moment I draw the
Yeah.
EMF joint table, it was quite clear that the calculation was not too much. So such
Oh,
kind of things were there, which while reading the question, it looked whether it's going to be calculation intensive, but when
mm-hmm.
I really attempted, it was not actually.
Okay, 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 okay. Thank you, Vimlesh. Thank you. Others, please do share your thoughts. Okay, we have Samit, Sandeep, Sailesh.
The paper was easy, but actually I made some calculation mistake in the very last step, so got two problems incorrect. Otherwise, paper is quite easy.
That
Okay, okay,
question on poison distribution, I mean, it was
okay.
on the patient number of patients who is going to show up. That was really, I mean, catchy. I mean, nicely worded. I mean, one has to catch the language, and then the problem is very easy.
Yeah, yeah, yeah. Even most of the question we didn't put much calculation because of this new like online also. Y-
But
You are
this
giving
time,
exam
since
in
This,
online mode.
no, this 0.55 cube and all,
Yeah,
the online calculator, it takes a little time compared to doing it on manual handheld calculator.
yeah.
but so this time, since it is
Question
pen
paper.
and paper exam, whether there will be any part marking because I have solved all the steps, and once I go through that,
No, no part marking.
No, no, I think some talk is going on regarding that because in master too, people are doing this thing. So, well,
if there is
they
10
will
steps,
mention
I
that too also.
till up to 9 it is correct, but the last step I made some calculation mistake.
In the feedback form, they
Okay,
also ask
possible we
in the feedback form,
give
sir. They
marks
also
per step, so you'll get definitely. Okay.
You are not audible, sir.
Yeah. Mm,
Excuse me, sir.
yeah, yeah, yeah. Hello.
Hello.
Uh, Hello. Yes. Am I
Sir,
audible? Hello.
your voice is breaking up sometimes. So I don't know whether it's problem at my end or not. Can others confirm?
Okay.
yeah, yes, same issue.
Okay. Hello.
Yeah, sir.
Okay.
Much better. It's yeah, you are audible now, sir.
Okay. Okay. Yeah. Please
Sir,
do
I
share
wanted
your
to
thoughts.
ask something regarding this quiz.
Yes. Please.
Sir, as per the latest email we got, like July 11th, we'll get another chance. Those who want to appear for quiz one again in person.
Yes. Yeah.
So, but the problem with that is like for 4 subjects we are getting 3 hours. Is that the intention or is there some mistake, sir?
No. No. Even this.
Regarding this,
Even
in the
in.
forenoon session, it is 45 minutes per paper. That,
Yes. Yes.
Okay. So the time is okay. Fine.
Yeah. Yeah.
But but then in the second half, there we are getting 1 hour per paper, like 1 hour per subject. Okay. Okay, sir. Thank you.
Yeah, okay. And one more point, like I want to discuss with you guys, since you all are coming to live session. So we have seen the distribution of mark. So you guys are saying that paper was, it was okay, it was easy. Still, like we have got a big number who have like scored very less. And since in quiz one, major portion were from the start one itself, right? Week one and week two. So, like, what is your thoughts on this? Like, how we can improve all these things? Like, because we are seeing so like big number who have scored very less. So that
Hello,
is
sir.
not a good thing for us also, right? Yeah. Hello.
Hi, sir. This is Sandeep.
Sir, I think that is because of the technical problem. We got pressured, means it was so much pressure that the portal was not working efficiently, and it was after refreshing, it was copying the questions every time, multiple times.
Okay.
Another point I
So
can
that's
add
why
that
we were not able to give our 100% in the question paper. That's, I think, the mark got
Okay. So one
cut.
is the technical issue of the portal. Okay.
Yes,
Second thing is probably this time all the questions were numerical answer type.
Yeah.
So
yes, we have
normally
to write
when we
every
look at
answer on paper. That
when
was
we look at
also an
when we
issue.
look at the options, the multiple choice options, we get a clue on how to solve the question.
Yeah, it brings the more confidence when we have the MCQ. Yeah, I agree with that. Yeah. Yeah,
But
correct.
another point I can add that I also gave this as a feedback
Mm-hmm.
from the self-evaluation form.
Yeah,
That
yeah.
this time what happened, at least I can tell about my story.
Yeah,
My
yeah.
cons, I made two problem incorrect in the last step because of
Okay.
small calculation mistake only. Otherwise, everything it's okay. Means I know the how to solve this problem and I solve it in written down all these steps. But this has happened very less with statistics, but more with maths. I also in maths also paper is not difficult. Paper is more or less okay, but
Okay.
made a mistake in calculation mistake again there. But why in what I thought this time I am not able to concentrate it properly because of various reasons. One is this is the first time that all this arrangement and protocol I have to means do it, and at the same time I have to write the exam.
Yeah, yeah, all
And
these technical
another
stuff,
time
right?
I am not able to
Mm-hmm.
concentrate because of I'm at the same time my thought is if the power goes off, if the internet will go on, then my exam will be jeopardized. All these things make me some in
Okay. So concentration is
uncomfortable
difficult.
and
situation.
not only getting the answer, but to
Mm-hmm.
stepwise write the answer in such a, I mean, one in mathematics. If I talk about mathematics, one
Yeah,
of the questions was taking a page or more than 2 pages to complete the answer.
sure.
I mean,
Oh,
kind of thing was happening. So
okay.
one, I mean, more than answers, one gets irritated also, and that also, I mean, takes away the concentration. That is why.
Excuse me,
In
sir.
from exam
Yeah.
from home, what I feel sir from this experience, concentration is it's a much difficult. If it is a in center exam or in person exam in the center, then
Mm-hmm.
I may perform well.
Okay.
Sir,
Yeah,
excuse
please.
me. Yeah,
One
I
Yeah.
doubt,
wanted to
sir.
add one thing, sir.
Yeah, please.
Not notwithstanding the technical issues, I understand that there were some technical issues. This is the first time, so it's a given that we'll face some issues.
Mm-hmm.
One thing that I felt was like really lacking was the mock test. Like before in the previous exams, we had mock tests, or there was a session going on simultaneously with the test, so like we could understand the pattern of questions we'll get and everything. But
Okay.
in this time, while there was a mock test, the
Okay.
entire session was dedicated to solving technical issues that we faced during the mock test. So, or the full 1.5 hour or 2 hours that went entirely into solving the technical issues that I was facing with the apps. And I guess this
Okay.
was the case for most of the people. So
Okay.
this the mock thing was missing this time. That also hurt my chances, I feel.
As
Okay.
a, I mean, as
Yeah.
a
Okay.
back to the teaching team, I mean,
Mhm.
Basically, what we are saying that more practice sessions would have definitely helped improve the median score.
Okay. Okay.
Sir, I
So
have one doubt regarding this quiz.
okay. And what
Sir,
is your doubt?
will you evaluate also using our answer scripts? Because I don't know how I have done 50 many typo errors in the portal. Like in stats, I have got 4 correct in portal, but in
Mhm.
the answer script, I have written all the 7 answers correctly with and I have put them in a box, like highlighted the answer. So will you also check the answer script?
Yeah, like I said, there's talk going on regarding that. So we'll go through your answer script and we'll give if a half correct. So let's say we'll give some partial mark, and if it is full correct, we'll give you the full mark. So
Is it
there's
only
a
for stats or even for mathematics will it be true?
the talk is going on for the maths. So even like if this will happen for maths, so ultimately we'll do for all
I mean,
courses.
the approach
Sir,
is correct,
so the
but
percentage,
final answer is not correct due to some calculation mistake in between.
Mhm.
sir,
Then
so the
is that
percentage being
the right
shown in the
candidate for
portal.
partial marks?
Yeah, like if your answer, if you only got your you have done calculation mistake, you have done step correct, so you will be rewarded some. Yeah,
Okay, so the percentage is being shown in the portal. That is not final.
not yet. Yeah.
Okay, sir. Thank you.
Which percent? That is for assignment percentages.
Uh, hello? Hello?
Correct. Then your voice is breaking.
Hello.
Yes, sir, now it's
Now it's audible.
Hello.
This calculation mistake issue is more prevalent than you could imagine. I think there were issues like when I was submitting the answers, the previous answers that I had submitted was wiped out. So it was happening repeatedly. At one point, I thought, what is the point of getting the answer one if it is not getting registered with the website? So I took a pause of 5 minutes. The statistic question was very standard, but I also made some calculation mistake with the last step, which I'm not proud of. So unlike of me, because I lost my focus. The examination is an event that you have to be very focused about, and all these things really put us out of our zone. So couldn't really
I think
concentrate on what was important for the day.
in center exam, this problem may not be there. We
In-center exams are, yeah, I could
S-
totally concentrate on the exam in the
exactly.
in-center exam.
That will much better.
just hold on, guys. Sandeep, you were saying something I just missed. Can you repeat?
Yeah, there was this issue of when I
Hello.
was submitting the answer for a question, all the previous answers I had submitted to up to that point
Okay.
was getting wiped out. So I had to repeatedly submit my answers. Then after a long time, my proctor gave me a feedback that this is happening to a lot of people and people are working on this behind the curtains. So I had to wait with my answers. These are the things that shouldn't happen. That put me out of my zone. In statistics, I don't want to blow my own trumpet, but as far as statistics is concerned, my numbers are pretty well. I got over 90 in all the exams in the previous term, but this was the first time that I made some silly mistakes in the last few steps, and I lost a couple of questions.
Okay.
That is very uncharacteristic of
Okay.
me.
Okay. So did you write to the support explaining your problem?
Yeah, well, there was a feedback form that I had fully filled with details about
Okay.
these
Okay.
events.
Okay. Then definitely we'll see, and we'll see what can be done. Okay. Don't worry about that.
I have a
So one
Thank you
po-
so much for that reassurance.
Okay. Okay. Yeah. Yeah.
I have a
Who is-
question regarding quiz. the math question was very tough this time. Is this the level going to be for other quizzes, like in future, like in quiz 2 and quiz 3, will math will be difficult, or what?
Okay, before we like I say something on math. So how was the start quiz according to you?
I think it was okay. We had practiced these questions and activity and assignments, so we did get an idea. So we
Yeah.
got a lot of practice. In math, we didn't get any practice of these type of questions. So I think statistics was okay.
Okay, but even in the maths also some of the question are like a major portion of the question what I have heard is from the content itself.
No, they weren't. We
All of the questions were from content, even including the Riemann trapezoidal sum. But the thing is,
Yeah.
questions were so lengthy that solving them neatly on the paper and then uploading them, keeping that in mind, it was taking too much time, and also it is taking away the concentration.
I
One
think
is
you can
always
attribute it
worry
to
about.
what Prithudeep had to say. I think what the point Prithudeep made was really valid. There was a large disconnect between the nature of the question that was presented during the mock test and the nature of the questions in the final test. There was only 5 questions each for stat and math. In the mock test, I finished most of us finished, I think, in less than the scheduled time. But there are 8 questions, and all of the questions in math was very lengthy, calculation intensive. So that took a lot of time. And I actually had a very strange experience. I afterwards tried to solve all the problems that I couldn't in math paper, and I solved it pretty easily, relatively easily, and with lesser amount of time. So I think it's the collective effect of all these things, like all these technical issues and the unexpected length of the questions or the calculation.
And one more point to add to
Put us
that,
off
see,
our mark.
Yeah.
I feel that there could be many like me who don't have a secluded place to attempt the test from home, and I mean definitely there will be movement of people,
Yeah. Yeah,
and
yeah,
that will
correct.
take
Agree.
away the concentration that which happened in my case,
Yeah, yeah, agree.
which I had informed and in advance. I had even written to support team that this is what may happen during the exam, which happened. So all these things, in-person exam is preferable. I had written many times and given in my feedback also.
I think, sir, as you said, na, many of us has not able to score very good in statistics because the curve is towards lower side. Just I think because of many of these people, sir, have the same problem because of this lack of concentration will create the problem, and that is why the entire graph gets shifted that side. I think, sir.
Okay.
So one
Okay.
positive thing
Okay. So
specific to
yeah.
calculus, specific to statistics, was that
Yes.
you had notes for all the 3 weeks. So I could very quickly revise, and I was able, yeah, it was quite good that the notes were there.
Okay. Thank you. Now, for the coming provide your work on week.
Your voice is breaking, sir.
I'm making from onwards. Hello.
Yes, sir. Now you are
Yeah,
audible.
yeah. Sorry, I just lost due to connection. Yeah. So I was saying that for onwards we are working on that. So we'll provide you all the formula sheet for coming weeks also.
And more practice papers, like there are definitely assignment questions which are already there, activity
Yeah.
questions and practice questions, but
Yeah.
fresh set of questions covering all the concepts, big
Aren't
one.
Yes, yes, yes.
If I mean kind of model papers. One is
Okay.
definitely given mock test and all, but suppose there are 4 5 model papers like mock test model papers. That will,
Okay.
I mean, help us to practice, and definitely it will help their score.
Okay, okay. And also this Monday we are planning one session with sir. That is revision of week 4, 5, and 6, like sir did last week for week 1, 2, 3.
Yes, yes.
So there will be one session by sir for week 4, 5, and 6.
In my feedback regarding particular topics which need to be taken care in one of the sessions, I had given
Yes.
feedback on Monte Carlo and Chevises, which has not been taken up till date.
No, no, but that topics include in week 4, right? If
Yes,
I'm
it was
correct.
told that it subsequently it will be taken in one of the subsequent. I'm saying till date that has not been taken up.
Okay, so in the coming session when it will be on Monday. So even on that topic we have got so many like feedback from so many people. So definitely there will be some questions on that topic. So please
No,
do
solving
join that.
questions is definitely one thing, but
Yes.
if someone can briefly explain these two concepts, taking, I mean, explaining the concept and with a couple of examples in varied scenarios, that will help understand. I mean, just understanding the formula is not going to help if
Mhm.
one cannot apply it in various situations.
Yeah, agree. Even the course is designed for that. If you can't apply something to the real world data or to something which you get new other than the book, so yeah, there will be no point. Yeah, correct. So please do attend the session of sir. If still your
No,
doubt it doesn't clear, so we'll plan something on that. Okay.
Sir, if the
yes,
session, is
I
it
had
possible to
attended.
conduct the
I had
session at
Wait,
submit
7 to 9
just
like
check.
that's like
Samit,
this time?
just hold on.
Okay, okay,
Yeah,
okay.
yeah.
I had attended the session of Professor Andrew, which was
Hmm.
quite helpful also. But it
Hmm.
was kind of like one-way communication in which he had to definitely cover, given the time, all the questions given time constraint. And definitely those 30 questions were, I mean, like make or break for the quiz.
Hmm.
But
Hmm.
explaining the concept will definitely take another session, in which someone, any of you, might explain these two concepts,
Okay.
and then take up some questions which will further instill the concept with confidence.
Excuse me, sir.
Okay. Yeah,
Sir, your audio is lagging once again.
okay, but I can hear you properly. Hello. Yeah,
Hello.
yeah. Can you hear me now? Hello.
Yes, sir, you are audible.
Okay,
Uh,
okay.
Sir,
Yeah.
I just wanted to raise another point. Like whatever Bimlesh said, he's absolutely correct. Like in the first revision session, I felt that Professor Andrew was like going very fast, but he had a lot of ground to cover as well.
Yes,
But
correct.
he had said that the questions would be shared, like the questions and the worked out solutions that he made on Google Jamboard,
Yes.
that would be shared with us. And like just the day before the exam, I thought of searching for them and I did not get them.
Yeah,
So
it was
But
available, Prito, in the
it was
dashboard.
available on that same day or day. One day after I upload. I asked the operational team and verified also. It was there on the portal.
No, I could
sir,
find them.
was it under the supplementary content section? Because maybe I maybe I missed them or
Yeah,
something.
that slide was in that. Yes.
Okay, okay. Then I'll recheck once again. But my suggestion for the next revision session would be like the previous one was very fast. So if time could be managed properly for the next one, maybe we can cover the whole thing. Or as Bimle
Okay.
said, like you can conduct a separate session like explaining the concept behind the questions, and in the
Hmm.
first one, Professor Andrew just explains the solutions and all.
Okay. Okay. Sure.
Yeah, thank you, sir.
Training session. Okay. Thank you.
Sir, I have one point to say, sir.
Yeah, before that, Samit, someone posted in the group. Yes, it is. This session is for week 7 activity question. I'll come to that. Don't worry about that. So once this feedback thing is done, I'll come back to that. Yeah, yeah, Samit, please.
Yeah, this is not regarding the quiz one. Actually,
Mm-hmm.
there is that extra activity that we are doing for the
Yes,
statistics.
yes.
Actually, sir, we are doing based on whatever we have been asked to do. But
Mm-hmm.
if that discussion, whether we are going, it's correct or wrong, whether our approach to is this real world data, how it is there any chance of discussion on this thing?
Not yet, but yeah, you guys can suggest if it is feasible, we can do.
At least one, maybe every 2 week, one open session for this discussion with this extra activity may help us. Actually,
Okay.
we are putting a lot of thought. This is the
Mm-hmm.
real time data and the
Mm-hmm.
concept we learn in the classroom. Try to marry these two. And
Mm-hmm.
actually, while trying to do, we are come up with many issues, but that get dumped there itself, because the kind of review system that we are having, it's just a very sketchy thing right as of now.
Mm-hmm.
But inside the data, if we could discuss, then it will be more interesting.
Okay.
That is a good idea.
In
Okay.
fact,
Yeah.
just to add to what Samit said, if
Yeah.
suppose already the activities which are already over, if you
Mm-hmm.
take us through model activities which had been already been submitted, or otherwise what kind of activity would have been expected, then that will help us understand what is being expected and how to approach the activity. And then from subsequent activity, you
So,
definitely get more submissions.
okay. I think for week zero, sir did something
Voice is cracking.
sir explained that. No, I'm just saying for week zero sir did something like that, right?
So not
Sir,
able
we
to hear
missed you,
you.
sir.
I'm just saying for week zero, Professor Andrew did something like that, right? In one of the session, he explained some of the data set, if I'm
Yes,
Yes,
sir.
correct,
He
yes.
right?
was,
With
yeah, IPL data
Jayakrishnan,
set.
I think they did one session like that.
No,
That you guys are saying, right?
how to do peer review and all, that is okay, but how to approach the given problem at hand.
Mhm.
If suppose a couple of examples can be taken through for already activities which are already over, then that will help us
Mhm.
people who have not done this in past, that will
Mhm.
help get a handle on how to approach or how to go about such kind of assignments.
Okay, okay,
Actually,
okay.
sir,
So,
what you are saying, sir, there is two things that what I understood. One
okay,
is when a problem is given to you, how to do that. How to
okay.
do that. This thing that what you are mentioning, Professor Andrew sir explained in the very first interaction with the with week zero activity.
Mhm.
But once you know how to do that, but once you did that and you come up with some real-time problem, that thing if discussed, then that problem will be more interesting. This part is not there, sir, unless and until we discuss exactly what is happening there, and after applying this theory in the
Mhm.
real data, if we discuss that thing, then that will be more interesting.
Okay, okay, okay. So yeah, I'll just discuss what is possible on all these things. So we'll plan something on that. Okay.
Okay, and sir, one more thing, sir, I will just try want to add here.
Okay.
In the activity questions,
Yeah.
what
Yes.
happen when we go through some video lectures, then we jump into the activity question and try to solve that, and whether our means concept is clear or not, or whether I'm able to do it or not, this thing. But what happen before exam,
Yes.
if we want to practice that, then
Okay.
if I go again the activity question, that toggle button is holding the answer. If you could
Mm-hmm.
at least means give one button which if I press it, all the answer get refreshed and start at fresh. This thing not happening, sir. When I try to access the activity question before exam, then all the answers there is there. It's not able to refresh that and make it a new paper. Is it possible to
Uh,
so
like that we have done in the quiz. You are talking about that parameterization of question. Like every time you refresh, you'll get new set of question.
yes, fine. Then the actually I don't remember all those things. Every time I come, I want to see the new thing. But
Mm-hmm.
if the answer is there, then it will be a little difficult.
Okay, so you want
If it is
answer
possible,
not to
then
be
provide
seen,
it.
or you want every time new set of.
Which
Oh,
means
okay. So
every
you
time,
want
whenever
like
I
answer
access,
will
it will
not
be
be visible.
yes. I will put it and I will check it whether I am correct or wrong. Or else you can, if this is
Can you have this
difficult,
opportunity?
no, sir. If it this is if this is
Mhm.
difficult, if you can give us a access to make a PDF of this question paper, then it'll okay. Then I can make the PDF and use in my convenient way.
Okay. So that we can do. Like, okay, if you want PDF, we can
At least you
provide you
give the
the
PDF,
PDF.
sir.
That is
Yes. Then
doable.
I am able to see the question paper every time is a new version, new one.
Okay. Okay. Sure. Okay. So that is doable. I'll see what can be done at like at which pace. Okay. That is doable.
Hello, sir.
Yeah. Hello,
Sir, I
Smriti.
have a doubt. Yes, sir, I have a doubt regarding quiz two. In mail, it was said that quiz two will be based on week 5 to week 9, right?
Yes.
But sir, in statistics, it's going week 7. So week 9 will deadline will be 14th July. Then it will be week 5 to week 8, right?
Yeah. So if you go through the semester that curriculum, so it should be the release of let's say this Friday should be the release of ninth week, right? But
Right, sir.
will be releasing week 8.
8.
So
Hmm.
consider this as your week 9.
Okay.
Okay. So 5 to 9 means in statistic 2 it is 5 to 8. So it will be
Okay.
1 to 4, 5 to 9, 4 chapter each.
Hmm.
Okay.
So
1 to
basically
4
week
and
5
5 to
to week
8.
8.
Yes, that is basically 5, 6, 7, 8. Yes.
Hmm.
Yeah.
Okay, sir.
Yeah.
Thank you.
Okay. Let's move to the activity questions then. We collected, yeah, some of the feedback. We'll discuss this within the team and we'll see what can be avoided. Yeah. Thank you all for providing the feedback. Okay, let's
I
move
also
to
really
the.
appreciate. I also really appreciate this effort by you for taking the feedback from us. Thank you.
Okay. Thank you. Okay.
Hello, sir.
Yes.
Sir, in July 11, the questions will be MCQ or MSQ type, right?
So if it is like in like on center in person exam, so
Hmm.
it will be all like collect combination of all MCQ, MSQ, and AT everything.
Like previous type, right?
Yes. Like
Okay,
previously
sir.
you used to get. Yeah.
Hmm. Thank you.
Okay. Okay. So someone was asking questions from week 7 activity. So we'll move to week 7 activity. So before proceeding week 7, just one more thing. So in week 7, you have seen so many definitions, right? Mostly very less numerical, and so like most of the content are regarding the definition. Try to learn some of the definitions, like weak law of large number, and one is more, that is MGF, and the other is CLT. Okay, these three concepts are very important in that chapter. There are some mathematical process also involved in some of the definitions, and some of them if you don't understand, then it's okay. But if you try to learn the definition, try to understand the definitions of these three concepts: weak law of large number, central limit theorem, and okay. You guys heard whatever I just
Your voice is breaking.
Smith. Hello. Am I audible? Hello.
Yes,
Now
now
you are
audible.
audible, sir.
Okay, okay. So I'm saying that in week 7, the 2-3 topics are very important. Please try to focus more on that topic: weak law of large number, MGF, and central limit theorem. And even if you don't understand in much detail about the mathematical, terminologies in other concept, it's okay. But try to make sure you understand all the definitions. You have understanding of the definitions because it will be used in further weeks.
Sir, one clarity, a confusion I have in the
Yes.
concentration phenomena and the
Yes.
central limit theory.
Mm-hmm.
Is the central limit theory is the extended version of the concentration phenomena?
Concentration phenomena. So when you are saying concentration phenomena, what exactly are you referring? Because in that, sir has done some of the, if I remember correctly, some of the calculations, right?
Yes.
Let me check again. Okay, some bounds, Chernoff bounds, and MGF and Chernoff bound.
If
Okay,
you could, if
even
you
if you,
can,
yeah, yeah.
if you can explain this concentration phenomena, MGF and central limit theory, because these three are, I'm seeing these three are is very close to each other, but not able to get a very good clarity on these three.
See,
I
if you have understand weak law of large number, MGF, and the central limit theorem, okay, that will work for you. If you know the mathematical derivation and their understanding of all these topic, I think week 7 is okay for you. Don't go too much in concentration phenomena.
okay.
If you
But
see our
if you can give some
assignments,
clarity.
even yeah, okay. Can you pick some examples? Because see, sir has done all the particular questions. Like if you pick delta and you want to bound that thing, okay, so you can bound in that range. All these mathematical things. So you can go through and you can ask on that thing, right?
Uh, okay, actually, sir, what happened means I am confused in his definition only because uh, central limit theory, it's
Mm-hmm.
saying ki is a data where the concentration is happening, right?
Okay.
And the concentration phenomenon, how these two is different, I am not able to get it up. Because sir said with some example how to do that, but I am not able to figure it out what is the difference between these two.
Even I'm not able to understand what exactly are you asking. Can you reframe to something?
Okay, I am finding some problem.
Like
Meantime,
if
you, yeah.
anyone is okay,
Hello.
okay, sure.
Can I get
Okay,
clarity
let's
over
move to the
activity 7.6 Q4?
okay 7.6 question. Can you repeat the
Question 4. I mean, it is I mean, central
hello?
limit theorem, but yeah, 7.6 question number 4.
Yes, yes. Just
Yeah, sure. I mean, it's dependent on Poisson and central
okay.
limit theorem.
Just hold on. Hold on. Okay. So what exactly is your doubt in this? It's poison and yeah, correct. Hello.
I mean, I couldn't get. I mean, what's 410 in there?
Okay.
I mean, fourth question. I mean,
Oh,
model that again for
okay.
the
Okay. Okay.
365 days and uh,
Okay. Okay. I'll solve. Okay. Just
yeah, sure.
so this is the question, right? The number of accident in a certain city is modeled by Poisson random variable with average 9 accident per day, and the number of accident on different days are independent. You have to use CLT to find the probability that there will be more than 3,300 accident in a certain year. In that 365 days in a year, right?
Sir, a little louder, sir.
Okay. 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 Let me open now. Okay. So you all can see my screen. Hello.
Yes, sir. It's visible.
Uh, okay. Whiteboard is visual, right?
Yes, yes.
Okay. So you have to find the probability. Suppose I'm saying that X, that number of accident in a year, and you have 365 days in a year. Okay. So you can consider this X as complete of 365 days, and you can split this as X1, X2 till 365. Okay, you can consider number of accident, you can model these number of accident in each day as a Poisson distribution. Okay, so ultimately what you have to find as probability of x1 x2 till x365 is greater than 300, sorry, 3300, right? Now what you can do, you can use here CLT, center limit theorem. So there are two different versions you can write for CLT. One is, let's say your random variable y is following following some distribution, normal distribution, okay, with mean mu. So you can write this nu n times mu upon sigma root n. This will follow normal 0 comma 1. Hello, you all can see, you can hear, right?
Yeah, yeah.
Yes,
Yes,
sir.
audible.
Yeah, so this y here x1 plus x2 plus x360, sorry, 365. Now you have mu is 9. Okay, so what you do, you just use I'll write this as y bar. Okay, so y bar greater than, do the use the CLT. N is here 365, right? Mu, that is average. Average is here 9 upon sigma. So you have variance is also sigma. Sorry, the average value 9, but you have to take division. So it will be 3 into, okay, greater than, same you do to the right side. 65 into, sorry, 9 upon 3 into 365. Okay, so this, now you can write this as upon, so 3 divided
Nothing is audible.
hello.
Sir, please repeat, sir.
Okay, wait.
Not able to hear you
Probability
anything
of,
in between.
okay, so you have to find the probability that number of accident in a year is greater than 3300, right? You can hear me right now, right?
Yes.
Yes, sir.
Yes.
Okay. Okay, so you can model each day as a Poisson distribution with mean 9, like average number of accident as 9. And you know that Poisson distribution variance is also the value of average, that is lambda itself. So the sigma square will be 9, so sigma will be 3. You have to just use the CLT here. For CLT, what you do, you subtract it with n times mu and divide it by sigma into root n. So you do this to the right side, you will get the value that probability of G. Now it is standard normal distribution is greater than 5 upon root 365. That you will get 1 minus P of G less than equal to 0.626. Now check the value of normal table, like from the normal table you can check this distribution value and you can answer the question.
Okay.
Who asked this question? Is it clear or
Yeah. One second. So n is not according to the year. 365. N is 365.
yes, because I'm asking you the number of accident in a year can be greater than 3300, right?
Yeah, yeah.
So you can model each day as a Poisson distribution and with
Okay.
average number of accident as 9, correct?
Yeah. Got it.
Okay.
So, can you please explain weak law of numbers and MGF?
Okay, so weak law of large number, if you go through. Okay, so wait, I'll just open the where's the weak law of large number. Okay. Do I need to use the whiteboard explaining the expression, or just I have to give the definition?
So, like, I'm very confused. I don't understand anything, this inequality or anything. I'm struggling with these concepts. I don't understand anything in the video. You can use whiteboard if you want.
Okay, okay, okay. Wait. So weak of large number. Okay. So have you seen the definition?
Yes, so
So you have random variable. Okay. Oh, hello.
Visible, but audio now it is coming.
Yeah, yeah, yeah. Okay. So yes. Okay. So suppose you have n random variable x1, x2, xn. Now you are defining one new random variable as x1, sum of all these. Okay. Now, since you are collecting these samples, okay, for estimating the average value. Okay, you're collecting these samples for estimating the average value. So basically weak law of large number is saying say that if you collect a large amount of sample, is there any way so that you can say with some certainty that my average value lie in this interval? Okay, so if you see the definition even, so I collected the samples from the distribution. Every time I'm collecting the sample as x1 x2 dot xn samples I'm collecting. I'm defining something as a sample mean, which is the this summation by that number. Okay, so can I say that with some probability, what is the with some probability can I give some measurement that whatever I'm collecting, this will be close to my the close estimate to my average value, right? So that is the expression. So with probability more than 1 minus sigma square and del square, I'm saying that sample mean lies in this interval. So it's just, so every time I'm collecting sample, so weak law of large number says that every time you collect the sample, so what is the guarantee? Okay, so whatever you are collecting, it will approximate the average value or mu value. Okay, so it just like it's giving some bound to us. Whenever you collect the sample with probability this amount, it certainly says that mu value lies in this interval. Okay, that is the only interpretation of weak law of large number. With certain probability we are collecting every time samples, with certain probability we are saying that our mean value will lies in this interval. So basically we are giving some bound to that. Hello?
If you're writing anything, then it's not coming.
No, I'm not writing, I'm just explaining right now. Hello?
Yes, sir.
Yeah. See, the government has given a definition, let's say,
So your voice is breaking.
as mu. Hello? Hello?
Yes, sir, you're audible.
Yeah, yeah. So when see your x1, what are the x1 next to xn? You understand this, right?
Yeah, like you just took some sample, not the entire population, but just some sample, and you want to say that mean value will be in this small sample, right?
Yeah. So yeah, correct. So what we are doing, we are collecting samples, and we are saying with this probability, can I bound that this whatever estimate like I'm getting from these samples while after collecting the sample, whatever value I'm getting, can I say with some probability that it will be close enough to my mu value? So it's giving only the estimation. So basically we have found one law that guarantee this thing. So whenever you collect the sample, you can say with this probability my sample mean lies in this, and that will be used in estimation when you do parameter estimation. Suppose you don't know, let's say you want to estimate the average value of some distribution, but you don't know the exact like the exact value of the estimation. What you do, you can do the sampling. Every time you do the sampling, you just you define your x bar. So whenever you do the sampling, you will get some number. So how close you are getting that number to the actual value, to actual mean. So with this law you can guarantee this. With this certain probability, I'm saying that this will be in this range. So that much I can estimate.
Just one doubt, can I
Yes.
ask?
Yes.
Sir, what I understood, sir, suppose I do not know the distribution of the data. Now, what
Yes.
I will do, say suppose I have to collect 200
Hmm.
sample points, but
Hmm.
I collected in 10 intervals. Each intervals I am collecting 20 samples. Like that, there is 10 interval, total I am collecting 200 samples, right?
Okay.
So
Okay.
in this 200 sample, if I said this is my population, then that population will have some mean and variance. But
Okay.
now this is the background scenario. Now I do not know about that 200 points. Now
Okay.
I have just do the first sampling where I collected the 20 samples. Now from
Okay.
that 20 sample I will get some sample mean and sample variance. Now sir, what you are
Yes.
saying,
Correct.
when I will do the next sampling, then I
Hmm.
will start comparing with this existing one.
Start comparing with this existing one.
Means this bound, sir, this bound you are saying na ki this will vary within this bound, then actual mean means that 200 sample mean, or that the sample mean I got the previous sampling.
Okay. 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 So whatever mean you are getting, that mean that your sample mean will lie in this interval with some probability. Yeah, from this experiment you will get it. But since if you are choosing your sample which is not near to the interval, then you will get very less probability,
Sir, please, your
and
voice
that
is
will
breaking,
lead
sir.
to
Not,
the no possibility of it.
can you repeat, sir? I am not able to hear you.
Wait. So I'm saying that if you ever like you are picking points from the intervals, right?
Hmm.
You are making intervals, and you are picking 20 points from one of the interval and saying, can you use this law? I'm saying if you will use this law, you will get some probability, but that probability will be very less, because your actual value may lie to the other side. The actual value of mean may lie to the other side, so with very little probability this will happen.
Acha.
No, but
Okay.
here 200 instances are actually population.
Hmm.
So whatever is the mean of 200 and then dividing 200 in subgroups of 20 each, so 10
Hmm.
subgroups, then
Hmm.
can we apply this law on such subgroups?
No. See, you are see the sampling. Even let's say you are not applying anything, this subgroup thing and all. The sample which you took, because you are taking random sample, it might be possible that it belongs to your one of the intervals, right? You are not sure about that. That's why it is called that x bar is a random. So you keep doing this unless you get a good result, and there comes the parameter estimation.
Hello, sir. Sir Shubham this side.
Okay, sir. Uh,
Sir, I have a doubt regarding the lecture, like the notation in the lectures. So in the lectures, so I just want to know, in the lectures, sir has used capital X, X1, X2, X3 till Xn as IIDX. So just
Okay.
want to know whether, and in some examples we have used small x1, small x2 till small xn. So just want to know
Mhm.
whether this, what I understood, maybe you can correct me. These capital X, what I
Mhm.
understood are the samplings, and each x1 can have many small x1, like x1, x2, x3 up to xn. So is this
Okay.
understanding
Okay.
correct or not?
Yeah, like for each sampling you are like, see, x1, x2, x till xn, these are the random variables. But when you say a sampling or sampling instance, that means you are getting one value corresponding to the random variable x1, one value corresponding to the random variable x2, and that you are denoting as small x1, small x2 till small xn.
So in reality, the capital X1 is a value only. It is not like capital X1 has
No,
inside
it's
that
a
many
random
values.
variable, right? It's a random variable. See,
Okay.
when I define x follows the binomial random variable, but
Huh.
I also ask you to find the probability. What is the probability? X will take value 2,
Okay. Okay.
right? So in
Yes.
that way, I'm saying x1, x2, all these are random variable, but for if you do the sampling, they will take some values, right?
Okay. So that values are small x1, small x2, small
Yes,
x3 till small
yes,
xn.
yes.
Okay, okay, okay. So in reality, the capital X well is like when we are going to ask that. Okay, regarding that, we can ask like whether x1 can take value between a range or x1 can take a particular value or anything we can ask of that random variable. Am correct, sir?
Yes,
Okay, I got it. Thank you.
yes, yes.
So the mu you mentioned is the mean of the whole population, right?
Hmm.
Yes.
Yeah, can you repeat, Mehak?
So in weak law, there's
Hello.
hello. In weak
Yeah, yeah,
law,
yeah.
mu is written. So
Mhm.
mu is the mean of the entire population, right?
Yes, yes, correct.
But how do we get the mean of the entire population?
No, no, we don't get the exact mean of the population. That's why we do the estimation, right? So in the coming week, so in the week 8, you will all study this estimation theory. How you can estimate some parameter of the distribution, and that parameter can be the mu also. That means the average also. You
And
don't, yeah.
so what does it mean that with probability more than one minus
No, no. See,
sample
you are
lies?
not certain about this. See, you are doing sampling, right? So these things are random. So you don't know for sure, like for certain it will happen. That's why you are using the word probability. With this probability, you can comment on this.
What does this mean? One minus this sample mean lies in this range mu plus minus delta mu.
If you see the expression probability of x bar minus mu mod less than greater than delta less than sigma square and delta square del square, right? You can write this as 1 minus p of less than equal to del, right? So
It
you
on
just you,
whiteboard.
okay. Okay, so initially you have this expression, right? Right?
Yes, sir.
You can write this also, and that you can write as, sorry, it's x bar. Correct.
Yes, sir.
Yeah. So
So
in
this
the second line, we are saying this. You see the last expression. The probability that this sample mean lies between in this interval is greater than 1 minus sigma square by n del square.
yes, sir.
I hope you understood this.
And so the value of delta is something which we give. We can give any value of delta, any value which we
Yeah. So yes, yes. So we are giving. See, if you are certain that your value will be accurate, so you can make delta as small as possible, right? But see, whenever we write delta, it's a small positive quantity, because if it will be a big number, so there won't be any point in estimating this.
so I don't understand why do I need to make delta small?
See, if your delta will be big, so see, if I say you have an interval 2 to 10, and I'm asking you to a random value, and you have to give me some range in that interval, so that you can say for certain this value lies in this small interval. Okay, so let's say if I say whatever value you are seeking, that lies on the whole real line. So what information can you get from that? It's a very vague. but the moment you try to make that interval smaller, let's say you are giving me 2 to 10, now you are saying that point is in between 2 to 10. Okay, now some concrete like some amount of information we can get, right? Now you try to make that interval like more thinner, let's say point minus point 0.5 to point 0.5. Okay, so now when I said my this point lies in this range, right? So now I can get some concrete information. Okay, I'll bound on the left side, I'll bound on the right side, and based on this information I can do some work and get some output. That's why we are putting delta, we are putting small bound.
To get a better value.
Yes, better estimations, yes.
So people just put different values to see where they can find. They do it several times to see which delta.
Yes, so whenever you are estimating, you want to, so basically in the estimation what you do, you try to minimize your error. So how can, like, how close I can predict this thing? That's why people keep the value of delta as small as it is possible.
So can you explain Chebyshev, Markov, and all these inequalities?
Okay, I can, but that sir will explain or we'll do some questions in the session. If not, we'll do some sessions because so many people are asking and it's week 7 activity. So yeah, we can do, but yeah, we'll prepare something and then we'll explain in a more, you know, more presentable form. Hello.
Yes, I mean,
Hello.
some questions which are not straightforward, but which need this inequality,
Yes.
but not a straightforward application.
Yeah, like you are asking the question right now, like explain some question that based on weak law of large number.
No, no, no. This Markov and Chebyshev, which
Yeah,
you
yeah,
use
yeah,
at
yeah.
the
So
stage. So, taking situation in which there is no direct application, but then these inequalities are used for solving problems.
okay, sure. Yeah. So that we'll do in some other session, or if sir will not do, we'll do in some other session.
No, no, he will definitely do. But what he'll do, he'll take questions and take us varied situations, take us through that, and that will definitely help the
Mhm.
application part. But then in some session, if you can take half an hour session for explaining the concept through some examples.
Okay, okay, okay. We'll see when it can be done, but yeah, we'll see. Okay. Any other question related week 7 activity?
Yeah, week 7, the activity 7.6 Q6. I mean, the I want to
Seven point
moment
six.
of a function. I mean, value of sixth moment given the normal distribution.
Okay. So what do you understand by moment? What
Moment
exactly
is
you have
base.
to find?
Yeah, yeah. Basically, e power x is mean. E power x square gives us variance. E power x cube gives qness, something of that sort. I mean, it defines the values in the stats. I mean, the given distribution basically. The moment defines some shape or some uh, characteristics of that particular distribution. The moment will give the idea about that.
Okay, so basically, when you find out e power expectation of x, you call it first moment. Expectation
Yeah,
of x square, it is called second moment. So, like the
yeah,
way if you go e to the power, it's a expectation of x power 6. So, this is called the sixth moment, right?
yeah.
And also, you when you find the moment, you write as e to the power lambda x, right? So, when you define the moment, moment and mgf, when you define the mgf, right?
Okay,
So you write as the expectation of e to the power lambda x is the moment generating function for the random variable x, right?
Okay.
Okay, so when you use the e to the power x expansion, right? 1
Yeah.
x
Okay.
plus x
Yeah.
square by 2 and all,
Yeah.
and you know that moment generating function will converge to normal 0 1, and that value will be e lambda square sigma square by 2, right?
Sorry, I couldn't get this body for.
You remember if you have seen the,
I
sorry,
mean,
can you repeat? Yeah.
I couldn't get this e power x minus x square
The
by some
mgf
lambda power.
the mgf of normal distribution will converge to the e to the power lambda square sigma square by 2. This
Okay.
you know, right? Or you have seen in the lecture. uh just let me know you have seen in the lecture, or you know.
No, no, no. I haven't seen that. Sorry. Uh, could you
Hello.
solve that if possible?
Okay, it's okay. Okay, okay, okay. Just give me a few seconds. Yeah. So if x is a if x is a random variable, okay, with mean 0.
Yeah.
You can hear me, right?
Yeah, yeah, I can.
If you see this, if x is a, so mgf of normal, if x is a distribution that with mean 0 and variance sigma square, okay,
Okay.
then the
Yeah.
mgf of that will converge to the e to the power lambda square sigma square by 2. This result, if you don't know, I'll suggest you just remember this:
Okay.
e to the power lambda square sigma square by 2. Okay, now use the expansion of e to the power x. You can write this as x plus x square by 2 factorial x cube by 3 factorial, like this, right?
Yeah. Okay.
Use the same here also. 1 plus, in place of x you have lambda square
Lambda square sigma square by 2. Yeah.
plus
And so
2
on. I
4,
can go on with. Okay. Got
okay, 2 to the power 2 2 factorial x cube, so it will be 6, to the power 3 3 factorial. So on 6 you'll get, so it's 1 2 3 4 5 6, so you'll get I think 12, right?
Yeah. 4 factor.
No, no, not 4, 6 factorial you'll
Okay.
get,
6
right?
factor.
On the 6th component,
Yeah. Okay.
6 moment, right? And now when you write the general mgf, so you write this expression.
E power lambda 6. Okay.
No, no, lambda x. This
Okay.
is the
Okay.
mgf for any random variable x, right?
Yeah. Yeah. Okay. 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 General. Okay.
So write either power x. Again, you can write same here also. Lambda x, lambda square, write small x, lambda cube, x cube by 3 factorial, like this. Okay, you can compare from here to here the coefficient, and then you'll
Okay.
get the
Okay.
value. In
But
place of, in place of sigma, you have to write whatever value you have.
okay. Got it. Got it. Okay.
Okay.
I only need the sixth variable. That's it, right?
Yeah, that power, that
The
power.
yeah, coefficient. Okay.
Yeah, that power coefficient.
Okay. Got it. Got it. Thank you.
Okay.
Which all expansions do we need to remember?
Like I said, from week 7, if you know the weak law of large number, moment generating function, and the CLT. So these are the important concept for you guys, because if you go into the concentration phenomena, it
I
will
know.
involve.
I was asking about like e to power x expansion is there. We need to remember that. So likewise, any more expansions we need to remember like log x and all.
Few expansion
Because
if you
if we
know,
don't
it will be
remember, then
helpful.
solving such questions won't be possible. Hello.
Hello. Yeah, I'm saying that if you remember few of the you know expansion, it will be helpful.
So if,
Try
can
to.
be, if that can be included in the notes, that will definitely help.
Okay. We'll provide some list of this expansion which are necessary or which can be useful. We will provide this.
Thank
Okay.
you.
I think last semester also we have provided that. But yeah, if you are asking, we can give.
Sir, in discourse forum,
Yes.
I try to solve this integration, not this one, the earlier one, that PDF of normal distribution
Mm-hmm.
from minus infinity to infinity. But
Mm-hmm.
I solved a certain part and then no, I am not able to do it. I am taking these two in polar coordinate and try to solve that, but there I get stuck. Then I posted it, but nobody replied it, sir. Means reply means I till date no have haven't got any solution. Can you please look once more?
Okay, so what was your integration? If you have normal distribution, I suggest don't integrate. Just try to make in some closed form, and that you can do by squaring.
No,
That
that
is a very basic standard result people use whenever you have integration that involves the PDF of normal. Try to make it perfect square.
no, that is for I'm not talking about this exam or problem point of view.
Mhm.
I'm saying that if I try to integrate this minus infinity to plus infinity,
Mhm.
this normal PDF, then I'll get that answer now one.
Acha, okay. Oh, for verifying, right?
Yeah.
Yes.
In your leisure time, just check where I am going wrong or how to do that.
Can you
If
tag me
I
in that?
okay, okay.
Eh, so I'll get notification. I'll see. Okay. Okay. Any other questions regarding the activity? Hello. Hello. Am I audible?
Yes, sir, you're audible.
Okay. Thank you. Any other questions from week 7 activity?
So maybe I don't think a lot of people have doubts on activity questions. So I think a lot of people are like having problems with the concept. Uh,
So regarding the concept, like I said, for week 7, you can practice more on weak law of large number, moment generating function, and central limit theorem. Even if you don't go through the concentration phenomena, it's fine because that involves too much mathematical expression.
that won't come in exams.
Yeah, we'll not keep question from that side. Yeah. So even we were planning to release it
Your voice.
put much focus on that.
Can we lost?
Okay, anyone, any other doubt?
So can you explain central limit or NGF?
Okay, so
Sir, one small request, sir. In Mondays, since that is a working day, Monday this Professor Sir's class, can you arrange it from 7 p.m.?
yeah, it will be from 7 to 9 only.
Okay. Thank you.
So for CLT, there's a very basic logic of if you have a distribution. Okay, I'll just say this. Okay, so let's say your y is defined as the sum of these random variables, right? Then if you see the distribution of this will follow as whatever normal 0 comma 1 follows. This is the like the most important thing, or whatever you uh, just learn this, or just learn by heart this thing. If you have a x1 x2 till xn random variable, and if it is been asked the sum of these random, like sum of these random variable, you call it some other random variable, subtract it with n mu. Okay, so upon sigma root n, you standardize that this distribution will be same as that normal, whatever normal follows. So whatever values you want to calculate around this distribution, you can get from here by using the table.
It's kind of normalizing, correct?
Yes, yes.
So how does it compare with z equal to x minus mu by sigma?
Just repeat that. Z minus what you said.
Z standard normal x
Uh-huh.
minus mu by sigma. Z is equal to x minus mu by sigma. That is the thing. The
Z minus mu by.
any normal distribution, transforming that to standard normal distribution.
Yes, this.
X minus mu by sigma equal to z.
Mhm.
So this y minus n mu, I mean this simple limit theorem. This
Okay. Okay. So you want to see. Okay. Let me rephrase this as. You can write this as like this, right?
yes.
Right. Again, you can write this as. Now consider this as a random variable. What is the mean of this? Mu, right? What is the variance of this?
Fitted
Sigma square
value.
by n. Now compare with this. Hello.
Yes. So sigma will be
This is
sigma.
the same thing, right?
Correct.
So this is the another expression for whatever I have write in the starting. This is the another expression for this thing. Yeah, this, which we used to do as standardize the normal by subtracting the mean and dividing it by the standard deviation. So if you consider this as a random variable, so this mean will be mu, variance sigma square by n. So that standard deviation sigma by root n. This follows normal 0 comma 1. This is the CLT. Now we are giving a name to this because we use very frequently. And this, and why sir has mentioned in this chapter, because these derivation can be derived from the MGF. So that's why he mentioned the MGF. From MGF he derived the CLT. Hello.
So can you explain MGF?
Okay, so MGF. So for MGF, if you know, let's say you have a random variable x. X is your random variable, and you have to find the MGF of this. You can simply find the expectation of e to the power lambda x. So how you find the expectation of, see, let's forget about what is MGF. I'm asking you, x is a random variable, and now you have to find the expectation of e to the power lambda x. You can find out this, right? If it is discrete, you can use some summation e to the power lambda x and this. If it is integration, you can this, right? So the terminology for this is MGF. So when you have to find moment generating function for x, you need to find the expected value of e to the power lambda x. And why we introduce all this MGF thing? Because see, if you have seen the lecture, every MGF is associated with one of the distribution. Sometimes it very like it is not easy to do the calculation with the expression itself, then we do the calculation with the MGF. Even whatever you do, then like you used to find this expected value and the variance of the different distribution, you can do this by the MGF also. With the MGF, it made the calculation easy in some of the distribution. So MGF and the expected value or the distribution is a one-to-one function. Each distribution will correspond to one of the MGF. Whatever MGF you will give, I'll give you one distribution, or whatever distribution you'll give, I'll give you some MGF for this. So there's a uniqueness in that. You just know, but whenever you have a random variable x, you have been asked to find the MGF of that, you need to find the expected value of e to the power lambda x. Don't go into too much detail, that mathematical detail.
But I just want to know, like, why NGF? We want to, like, what does it give to us? What does it mean?
Okay, so like I said, each MGF can be associated with a unique distribution. So whenever you have the MGF, you can find out the distribution. Whenever you have the distribution, you can associate with the MGF. So even if you see some of the calculation in statistic, that is easily doable by MGF. When you study more about the MGF, you can find the like most of the properties of the distribution using this MGF property without going too much into the probability theory.
So if you want to know what distribution this is, we can find MGF, and then we can know that this is Bernoulli, this is exponential, like,
Yeah, yes, like I said, each distribution is uniquely mapping to like map to one MGF, and each MGF, like it's vice versa.
so does each distribution has a MGF number? Is it like fixed? Is it, do we have a table for that or what?
No, it's not a, you don't need to learn the table and all, but just know each distribution has a MGF.
So they have a number, fixed number, right?
Fixed number.
Yeah, like a Bernoulli MGF is this. If we get this number, then it means it is Bernoulli.
Yes, from the MGF you can trace back to the distribution, right?
So there's a number associated with each distribution which is fixed.
Then every time you mention number, I'm just confused. What you have been mean by the number?
MGF will give some number, right? Uh, when you
No, no.
solve,
Hello.
hello,
Yes.
MGF will give us a number at the end, right? If we solve this.
Okay, but see, you don't know the lambda, right? It will be a function in terms of lambda, right?
Yes,
So for every lambda, it will be a number. If you don't give me the lambda, it won't be a value, like that exact value.
so what?
It will be some expression in the form of lambda.
Okay. And that expression will be equal to the distribution. Will look like the distribution expression.
Yeah. So you have the MGF, you can give the distribution. Even we have put some question in the activity also. If you have the MGF, you can give the distribution. I'll just show you one of the question regarding that. Okay, let's go to 7.5. Yeah, so okay. So if you can see my screen, right? That portal screen. That question is visual to you, right?
Also,
Okay. Okay, now is it visible? That's question.
yes, sir.
Okay. So here, see, there are two ways you can find out the distribution of y here, right? One, you can find out the probability for each values by taking each, like every possibility, right?
Yes, sir.
Hello.
Yes, sir.
And the other way you can find out the other way will be you can find out the mgf of x, right? When you know of x, since x1 and x2 are following IID x,
So your voice is breaking.
will be the mgf of x to the okay I'll just you have seen the question, right?
Yes, sir.
Hello. So x was the random variable that was taking some particular values with some probability, and also x1 x2 follows IID x, and then you have been given y as x1 plus x2, and you have been asked find the distribution of y, right?
Yes.
Okay, so there are two ways you can do. So the one way you can find out the each possible values of x1 and y2, sorry x1 and x2, and once you get the range you can find the corresponding probabilities, right?
Yes, sir.
And the other way you just find the mgf of x. Okay, when you get the mgf of x, since x1 and x2 follows IID x, so mgf of y will be nothing but mgf of x to whole square. Now when you get the mgf, you just open the mgf and you will get the distribution of y. That is the logic for mgf in that question.
So why have we squared it?
See, if this is the property, right? If you gone through the lectures, you don't know if x1 x2 follows IID x, you know the mgf of x, and you have to find out the mgf of y, which is defined at the sum of that variable. So you have to just do the power. Let's say if here if you have n, okay, xn, so it will be n here. If you have two terms square, three term cube, n term, so power n. So mx matlab mgf of x to the power how many variables do you have, so that power. This is the property you
And
can see in the lectures.
MGF of each random variable is same because it is IID.
Yes.
So if a x1 minus x2,
Sorry.
if y is equal to x1 minus x2,
No, then you can't use. And but in that case the distribution, your distribution will be, it will be zero distribution if I'm correct, right?
if it is IID, then it is 0.
Yes.
Mhm.
I hope you have understood the role of mgf, right? Hello.
Yes, sir. So I have one question. Do we need to do centralized Bernoulli and all these things?
See, the centralized Bernoulli, we are doing centralized Bernoulli because when you find this mgf, right? So when you find the distribution, so whenever sir has defined the mgf, so sir has assumed with mean 0, expected value of that random variable is 0. So then he has defined mgf. So mgf, whenever you are defining mgf, make sure you have expected value of that random variable as 0. That's why sir is using everywhere find the mgf of centralized x. The moment you centralize that random variable, mean will be 0.
So what does centralized mean?
Centralized means you are subtracting each of the value with the expected value of that random variable. That is the centralized. So let's say Bernoulli is taking value 0 comma 1, right? Hello.
Yes, sir.
And the mean of that Bernoulli is p. So you have to centralize, so you have to just minus with 0 and you have to subtract with 1. You'll get minus p comma 1 minus p. Now these are the two values which are taken by your centralized random variable. corresponding to that, you have to define moment generating function. Okay.
So, like, I'm still didn't understand.
uh, like what you didn't understand, can you be a little specific?
I don't like. Do we have to subtract expected value from each random variable? Uh,
Yes.
because of that, one value becomes zero because expected values in that range.
Hmm.
I don't understand.
Okay, okay, wait. uh, so whenever you have to consider the mgf, let's say you have a random variable, so just check if that random variable has the expected value 0, then you go to the next step and then define the mgf, right? So I'm giving the definition of something and starting with some condition, so my definition is based on that thing. I'll define the mgf of that random variable. Okay, if the expected value of that random variable will be 0, so the moment I'm taking Bernoulli, it is taking value 0 comma 1, but I'm saying, so whenever I have to find the mgf, so since it is the expected value of Bernoulli will not be 0, expected value is ex. So what I'll do, I'll find out the mgf of the centralized Bernoulli, right? With the, what is the meaning of centralized? With each value I subtract the expectation. And why we do subtract the the moment I do the centralized thing, so this is the meaning of centralized, because I'm subtracting the expected value, right? So when, so now your random variable is x minus ex. Okay, so you can hear me, right? So now your random variable is x minus ex. The moment you start finding out the expectation of this, it will be e to x. So this will be a constant quantity. So expected value of a constant quantity is constant. So it will be 0. That's why we are doing first centralize that random variable and find the MGF.
Because it is ID's expected value. I mean, x is same, so that's why it's zero for every value.
No, no, it's not 0 for every value. I'm just saying, whenever you are finding the MGF of centralized Bernoulli, that means you are subtracting expected value of the Bernoulli distribution from each value of the Bernoulli distribution. Whatever values is in the range of Bernoulli, you have to just subtract it with the expected value. And it's not with only the Bernoulli. Whatever distribution you have, you have to calculate the expected value. If it is not 0 mean random variable, okay, and just subtract it with the whatever values you have in the range, and then find the mgf, and that mgf will correspond to the centralized random variable, not with the exact random variable. Sorry.
That means, sir, any distribution which is do not having the expected value of that random variable, taking that distribution is not zero,
Mm-hmm.
then this MGF that we are using f of x into e to the power lambda x, this
Mm-hmm.
function, we are
Mm-hmm.
not able to apply that, right?
Yes.
Then what is the generalized moment generating function, general form of MGF?
No, no, even you, yeah, see, if you define the MGF for general, so once you find out, see, the once you find out the centralized MGF, okay, so you have to do now the shifting. If you have seen in the lecture, if you do the shifting, then you can say this is the mgf of the actual distribution, which is not easy doing the shifting.
That I understood, sir. But
Okay.
if I, without shifting, I want to write a moment generating function of any random variable, can I write that?
No, so you start with expected value of that random variable is 0, then define like start writing the mgf for that random variable.
Oh, first I have to shift and then I have to write, or else
Yes.
there is no way to write that MGF.
No, so the definition start with let x be a random variable with expected value 0. Then the MGF is defined like this.
That is okay, but I am just asking whether this is anywhere possible. Suppose expected value of a random variable is not 0, but still
Hmm.
we can able to write the generalized form of MGF.
Yes.
What is that MGF?
Okay.
The
What is
general form of MGF?
that? See, like you need to find first the MGF for the centralized thing, and then you have to do the shifting, and then you will find. And the other way, general form of the MGF, I have to let me check in the slides. Is it defined other way or?
Why I am asking this, sir? Why this thing is comes in my mind?
Yeah. Mm-hmm.
Because
Mm-hmm.
suppose there is two random variable x1 and x2. Okay, I am defining a new random variable y
Mm-hmm.
is equal to x1 plus x2. If the expected value of x1 and expected
Okay.
value of x2 is 0, but that doesn't mean the expected value of y is 0, right?
Uh,
So in that case, if I want to write the
but
MGF
if
of y,
you are
then how?
wait, hold on. You are defining x1 plus x2, and you are saying expected value of x1 is 0, expected value of x2 is 0. So that will
Hmm.
automatically make expected value of y is 0, right?
Yes, yes,
You
yes.
understand my point,
But
right?
yeah, that is 0. But is it possible I have some random variable which each one is having the expectation is 0, but I am getting a new random variable y which is a function of this x1 x2 up to xn. Then is it necessary that
Mm-hmm.
expected value of y is 0?
Can you repeat this?
I am saying
Whatever you
ki
just mentioned, can you repeat, please?
suppose there is
Mm-hmm.
x1 x2 like xn random variable is there. Hello, can
Okay.
you hear me?
Yeah.
Hello.
Yes.
Okay,
Yeah.
then
Please go on. Yes, I
expect
can hear
x.
you.
Okay, expected value of x1 x2 dot dot up to xn is each all the value is 0.
You okay? So each
Expected value
xi
of
is
x
0.
if xi is 0.
Okay.
Now y is equal to function of xi,
Okay.
some function I don't know, some function is
Function
inside,
of xi, not the sum.
not the sum, function of something I don't know which function it
Okay.
is. But can I generalize,
Mm-hmm. Mm-hmm. Mm-hmm.
can I say since e of xi is 0, then e of y
No,
is
no,
0?
no. So since you were saying it can be any function of x1, x2, and all, so it doesn't like it is not necessary that expected value of y will also be 0.
Ah,
Because let's say I'll define x1 plus 2 the x1 plus till xn, I'm defining sum, and I'm adding one number. This is the
ah,
my function y,
hmm.
right? But the expected value of y will be 2.
Yes, then in that case, if I since this some function f of xi is defining the new random variable y, and I want to write the moment generating function of this new random variable y, then how to go about it?
Okay, so you are saying if the function has a non-zero expected value, then how to find the moment generating function, right?
Yes, yes.
Okay, let me check. So it will be some function of whatever we call with some probability. Okay, e to the power lambda x. It is defining as e to the power mgf of x. Okay, so the definition itself call as whenever you have a zero mean random variable, we defined as a mgf. So if you have a non-zero random variable, then yeah, you have to do the shifting work only. You cannot find directly the MJ.
Sure.
Yeah,
Okay.
even if you go through the lecture, so the moment definition start, let x be a zero main random variable, and then you define the MGF of x from R to R is a function.
Okay, sir. Okay. Okay.
Okay, any more questions?
So can you spell inequality?
Inequality, which inequality you are talking about?
Uh, Chernoff, Markov, and Chebyshev, all three.
See, even like I said, don't go too much into the concentration phenomena, but if you want to
Concentration phenomena. So I don't.
know the bound only, that I'll just explain the bound. Don't worry, just hold on. I'll just open the bound. Okay, so now bound. Can you give me the expression of sun of bound? I am not able to recall it.
So it's 1 by n delta square.
Okay, yeah, it's the see even with sun of bound, we are assuming that again. Wait. Okay, so sun of bound with, again we are assuming it will be, if it is a zero mean random variable, then we can use the sun of bound. So sun of bound says that if you have to find the probability that some event is greater than, let's say, some number. Okay, that if you can't find out with certainty, you can bound that, and that bound is less than like mgf upon a to the power lambda t. That I'll just write on the screen. So see, the basic logic behind the bound is, whenever you have to calculate the probability of certain events, sometimes it is not possible to calculate the exact probability. Okay, so if we cannot calculate the probability, can we do, like, do we have some method where we can bound the such probability? Okay, so suppose we have expected value is 0. If this is the condition, and you have to find the probability that random variable is greater than some number, but that distribution is itself very, complicated, so you cannot find the exact value of this probability. So whenever we got stuck, we can't find the exact value of the probability, so what we do, since the probability value lies between 0 to 1, we try to find some bound, and these special results helps us for finding the bound. So this probability, by using set of bound, you can bound it with this, and this can be further bound. So this is the idea for set of bound. So
We will
hello.
we will never know the exact value, exact probability, but we will know bound. Like it is below this number.
Yes, yes. Yeah, so the idea behind, the idea behind the bound is that only we can't find the exact probability of that, with that condition. So can we have some bound? Can we say something informative, more informative? So these are the result which helps us in finding the bounds or in finding the results. So I'm saying that this probability cannot exceed the value of this, and since these are the functions, oh, so these can also be bounded by using maximization, right? Hello.
Yes, sir.
Yeah, so whatever bound you have, you go through the expression. Okay, try to see, whenever you see the expression, just Try to see whatever is given in the expression, try to remember that. And whenever you have been asked or whenever you do some derivation or theorem, so these bound will be helpful in deriving some results. You can't find the exact value of the probability, so there it will be helpful. With some certainty you can say okay this, but now you have t in the denominator. Okay, so you can make this as small as possible. So yeah, bound is only for these purposes. You can't find the exact probability. Can we get some number where we can say okay, this probability will lie in this interval. That is the only idea behind all these bounds.
So I didn't find this expression, but I found other expressions. So I only have to do the expression that we wrote. The other expressions that Sir gave, like there's so many expressions he gave in the lecture. I don't have
Yes.
to do that, right? I can just stick with the equation that you give me, right?
Can you repeat?
With the
Hello.
equations Sir gave in the lecture, do we have to like memorize all of the equations, or like do
No,
I
no. See, even if you do in your regular courses also, these are some special results which you can, like you have to memorize, right? You
need?
cannot derive every time these results. Even with the derivation also, you need to remember the conditions. Let's say whenever you have done your theorem in your college, in your school, even if you're passed or you're a working professional in your life, whenever you do the theorem derivation, you start with some condition. At least you should memorize those conditions and then you can get the result, right? So it's better to remember these results which can be directly applied for the questions.
There's so many questions in this week.
Yeah, so like I said, this week is mostly focused on the theoretical part. So these are some special bound which you can remember, right? Or you can just put that somewhere, because these are the bound which are going to help you in the coming weeks. Whenever you see something, okay, I'm using Sarnav bound and I'm concluding this result. So ultimately, as you go in the estimation and all, you have to use all these bounds to predict some nature. Okay, my value lies in this, my value lies in this. So these bounds will be helpful in there. Hello. Hello. Are we done here? Like no more questions, or if you have any question, please do ask. Otherwise, I'll wind up the session. It's almost done. So tomorrow there will be open session of week 7. Please do attend.
Okay, sir.
Okay. So no further, no more questions. Samit, Vimlesh, Mahak.
I do not have any question right now. If
Okay.
something,
Okay.
then
Thank
tomorrow.
you. Okay. Thank you. Okay
Yes,
then. Yeah.
sir, can you provide us with a formula sheet that we need to remember all the formulas? Like, can you
Yes.
write?
Yes. 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 We are working on that. So I'm hoping by Monday we'll release till week 6. And one two like after 1 or 2 days I'll release week 7 also.
Okay, sir. Thank you so much.
Sir, please, sir, discuss that the open session for the extra activity that what I
Yeah, yeah,
discussed.
yeah, I have noted down whatever points you guys have given me. I'll
Mhm.
discuss, surely I'll discuss this with team. See, whatever you are saying, even see for sure if we are not able to conduct for this sem, definitely we are going to do all these things for the coming session. Because see, whenever we try all these things, these are new for us also. So operationally we have to manage everything every time whatever new things came up. So all these things we have to take care, but yeah, we'll try to do some more. Yeah,
Okay.
surely.
Okay.
Okay. Okay, I'll wind up the session. Okay, thank you all.